to say we'll start at 9:35. Now it's 9:38. So first thing today, slightly different from last class. Since most of you are So since we knew that most of you are first interested in knowing what's your homework scores. So this time, some distribution. So if you can see this chart, this is how you guys scored. A lot of you didn't submit the homework. In fact, actually, I think that's the largest number of people who didn't submit or didn't submit it according to the instructions. So we got your homework, but we can't open the link, or there is no link. So at least the largest number of students who didn't submit, but more than 2/3 of you submitted, so that's good. And this is your ranges of scores. Not a very interesting chart. This is probably more helpful to see where you fit. It looks like evenly between 10 to 49, 100 to 129, 130 to 140, and 140 to 150, evenly, almost same number of you got those scores. So 13%, 17%, 18, 11, 13%. So almost same percentage in each of the groups. And 28% who didn't submit or didn't submit according to instructions. Hopefully this satisfies your curiosity about scores. We'll upload the scores if you haven't seen the scores already on the Agora Engineering Circle website or your Agora Math Circle website. We'll upload them, but we have evaluated all of your scores. I mentioned in session 1 that there'll be some sort of a badge system or honor system, and since you guys are in like 4 sections, this is, I think, based on sorting your scores. Now that I see, maybe I made some mistake in sorting. Well, I'll have to check if I did not do this right. But these are the names of students who scored high in each of your sections. I think each one has 18 to 20 students. So these are the names in each one. If there are any mistakes, we'll correct this. Maybe there is a mistake. At least I can spot one. So hopefully this satisfies your curiosity about how you did and how others did. And looks like most of you are doing pretty decently, actually. Anyone who scored more than 100, which is roughly about half of you, you have all done very well. Those of you who scored these lower scores, I think it's mostly problems with your submissions that caused this rather than you not doing it at all. Maybe you had a small mistake or something. So we'll have to, you probably read the instructions next time. We'll upload the scores. We'll upload the scores after this class. And then those of you who didn't submit, not sure if you didn't have time to mention, you have to submit it by the deadline. If you don't submit it by the deadline, if you keep asking for extensions, or if you submit late, even if you have done the homework, if you don't submit the homework before the deadline, but you didn't submit, that's a mistake on you. First time we let it go. This time we are not letting it go. Yeah, you can see your scores after this class or by the end of the day. So one thing that was brought to our attention by the coordinators who are evaluating your scores is most of you are probably getting the answers right. Those of you who attempted the homework are getting the answers right, but it looks like you're not doing it right. So if you write this code, while I equal to 0, I less than, I print I, this does something, right? This code, if you have to print the first 10 whole numbers, it will print the first 10 whole numbers. There is no problem with this. But this code has 2 problems which will only become obvious to you once you start writing code that's more than 2 lines long. Once you start writing hundreds of lines of code, then you will start realizing what's the problem with this particular code. There are 2 issues. One is it has very poor naming convention. So I'll zoom in my screen a little bit. Hopefully you can see now better. So this has very poor naming convention. What is I? Maybe you will understand today. Maybe you will not understand 2 months from now when you look at your code again. Or others whom you're collaborating with wouldn't understand. For you, I might mean something. For them, I might mean other thing. So this is one mistake that we have noticed everybody do. Your variable names, while they are immaterial, are essential. They don't matter with how code runs. You call it I or number or alpha, it will do the same thing. But how readable your code is differs a lot for whole number. So by looking at this code, almost everybody can guess that this is printing the first 10 whole numbers. By looking at I also, you can probably guess, but it's not as clear, right? This is unambiguous. The previous one has to be read. Another thing is you are missing comments. So you might have noticed me putting sometimes this pound sign and typing some stuff in uh, greenish color in this editor. The color may differ in other editors. Uh, it's what is called as comments. You can write anything about the code, why you are doing it that way, how you are doing it, some description of your code or what it does. It can be anything, but as long as you should have some comment in almost all of your code. Otherwise, others cannot see and understand what happens without reading through the code. So these are two things that we are grading for. So even if you got the correct answer and your code has poor variable names, and that's subjective, so we will decide whether your names are good or not. And if it doesn't have comments, you are not getting 100% of the score. So next time, remember these two things. Use good variable names and you write some comments to get full score, apart from getting the answer correct. If you only use comments and use variable names, you'll not get high scores. You'll just probably still get low score. Is this clear? Yeah, if you have used comments, you'll probably get good scores. Yeah, we have not uploaded the scores for session 2, so please don't keep worrying about that. We have not yet uploaded them. We'll upload. I wanted to go over this thing now that we have seen these scores. Session 1 scores have been uploaded. Last class, all of you have already complained about or inquired about why your scores were high or low. If any one of you can't see, at the end of the class, stay back and we'll go through each student's score to see. Yes, almost all programming languages have a comment thing because it's as I mentioned, it's more about readability. Yeah, right now for some questions, you're losing up to 40% points if you don't use comments and variable names because the code itself is small. We are focusing on making you write good code, not just some code. So in some cases, you might lose 2 points. In some cases, you might lose 4 points out of 10 points. It depends on the question probably, and it depends on the difficulty of the question itself. So if it's a difficult question and you got the answer right, you get most of the points. If it's an easy question and you got the answer right, but you don't have comments and good variable names, you get fewer points. Anyway, so any other questions?
Rajesh,
Yeah, so
this
in
is
this class,
Balaji.
hi Balaji, yeah.
I'm sorry, one more announcement. The students are not still putting their correct name, so we need to make sure that they do that. Otherwise, attendance will not be given. So can you please make an announcement?
Yeah. Guys, please rename yourself if you have used a different name to register to the session versus using a different name now. Please rename it so that we can see what your name is and mark you as present. Otherwise, you'll lose some points on your attendance. And if you miss 2 classes, then we'll kick you out of the course. Okay, so now I just sent a link on the chat window to all of you. Uh, in the next 12 minutes or so, so from 9:50 to 10 o'clock, you can access this link. This has 4 quiz questions. It's a quiz on the first two session material on the from the first two sessions. Okay, 1 second. Let me make it available to all.
Now we need permission.
Yeah, I'll make it available to all. Just give me a second. Okay, let me send another link. Hopefully this one works better. Can you please try this one? Okay, cool. Yeah. So actually, before you guys start on the quiz, what's wrong with this program that I wrote here? There is one big blunder. What's wrong with it?
You don't change the variable. You need whole number plus is equal to whole number plus 1.
Right. So what happens if I run this code now?
It'll be an infinite loop.
Perfect.
Just
Okay,
keep on
cool.
printing 0.
Yeah, I'll keep on printing 0. So infinite. Okay, good. So most of you may do well on the quiz then. Okay. Okay, so you can start the quiz. You only can submit one answer. So answer all 4 questions and click submit only once. For those of you who are unable to see the, yes, that is graded. Yeah. For those of you who can't see the link, please see the link here. Yeah, you can do it with a any user account. There is no yeah, I think you should be able to access. I think I made everybody get the link. You can the first question or the first item on the quiz is actually to choose the name of the student, right? So you choose your name there. Whatever is if you can't find your name in that list, that maybe I typed it wrong or maybe I didn't copy it correctly, you can type it in the question below. Yeah, you can use any email. uh, yeah, logical inconsistency. The word logical inconsistency means something that is illogical. So yeah, logical inconsistency means the code produces some result, but that is not what you think it would produce. So it does not seem logical. I mean, just so that you know, I mean, like I have this questions up, so you can choose from your names here. If in some cases I might have copied the names I see in some list. So if I miscopied or if you can't see your name, choose not found at the bottom and type your name in the next question. Please note that some questions have multiple answers. It's also there in the instruction. Some of them have multiple answers. Don't just choose one answer. You still have 7 more minutes, so there is no hurry in finishing it. If you want to check your answers back, some of them have multiple problems or multiple answers.
Wait, I have a question.
Yeah. For number 2, isn't it a matter of opinion on which you think is infrequent? Yeah, Shruti, Sai, Shreya, Satya. Yeah, it's probably, but if you then if it's a matter of opinion, if you can justify your answer, if you got a wrong answer, if you can justify your answer at the end of the class, we can talk about that one.
Okay.
It's not as much a matter of opinion. It's mostly certain things are very hard to do. We can discuss it at the end.
Yeah, I think question 2 is also an opinion question.
No, Jonathan, actually, yeah, it is. In some cases, it's probably opinion, but in some of the answers, it's very obvious you can't do that at all. So yeah, you choose the ones that are obviously hard or obviously infrequent. If you feel like something is based on opinion, then don't choose that answer. Yeah, I have to see actually if we get partial credit, because I think the way this Google Forms is set up, I think it only gives you either full correct or not. Yeah, we'll see. Depending on the responses, we'll see. Your scores are not final. We'll look into the scores at the end to see if it is okay. We may, if you got half of them right, maybe we'll give partial credit. But this one is not like. Let's see. Depending on how you guys are doing. Okay, 5 more minutes. You still have a lot of time. Go through questions in order, and so I already see 18 responses. It's good, very fast. Okay, 3 more minutes. Okay, you had some technical issues, Shreyan. Did you already submit it, Shreyan? Okay. Yeah, Shruti, that was there in the instructions. Quiz questions. Each question is worth 5 points. Some of them may have multiple corrections. choices. Please choose all correct choices. Yeah, you guys are being in a. Yeah, we'll look at partial credit. Looks like a lot of you didn't look at that instruction correctly. So we'll look at partial credit. Don't worry if you, and it's all relative to how others are doing, right? So if all of you missed it, then all of you, then we'll be forced to give partial credit. If some of you didn't miss it, then maybe we'll have to consider. Okay, 2 more minutes. So I only see about half the students submitted. So in the next 2 minutes, please submit. Otherwise, I'll just make the link offline. So maybe you can't submit. Okay, 47 or 46. 47. Yeah, we'll look into partial credit. Don't worry. We'll give you partial credit. Somebody asked something. When will a relatively, when would a relatively infrequent issue occur? It's so for question number 2, all loops can be made to have same kind of problems. It's just how easy it is to make it happen. I don't. I will stop sharing that. Can you see my screen? Hopefully, yeah. So all issues can happen for all loops. It's not impossible to make it happen. It's just sometimes very difficult for some of them. Very difficult in the sense, unless you are like sleeping and writing code, it's hard to have some of them happen versus the other issues. Both while loops and for loops have the same issues. Okay. Okay. Is Nikhilesh Kalyan Raman on the? Are you in the class? Vignesh, are you saying like you just joined the call? No, so you're late. That's okay. Next time, try to join soon. Okay, so now that we are almost at the end of time, I'll take the quiz offline. Okay, so okay. So hopefully all of you had enough time to answer all the questions. So now let's quickly go over the quiz questions. Did all of you finish submission? I see 62 responses. So if any of you, it didn't let you submit, yeah, that's probably because you didn't submit. So I'm enabling it for a couple of minutes. Please submit. Yeah, Vignesh, you joined late, right? So if you have joined late and you couldn't submit, that's sorry about that. Next time join early. Sai, Shriya, Satya, Matthew, and yes, I gave you. I allowed again for a couple of minutes, so till 10:04. If you guys want, you can submit. Okay, so you want the link again? Get the link again. Okay, you can, if you are unable to go back to the previous form with your answers, you can go to this form and choose answers till 10:04. So that's 2 minutes from now. Please try to submit. Okay, I'm taking the link offline. Let me check how many of you haven't submitted yet. I only see 66 responses, so hopefully that's all of you here. Balaji or somebody who is taking attendance. Do we only have 66 today, or do we have more? I see 85 in the Zoom session, but I only see 67, 66 responses.
Yeah, I'm compiling it. I will give, but 85 out of that, AEC is about 1, 2, 3, 4, 5, 6, 7, 8. So 85 minus 8 is about 77 should be there.
Okay, so some 10 of you haven't submitted, or 11 of you haven't submitted. For those of you who haven't submitted, please try to submit now. I'm taking it offline now. Okay. This is like rocket launch. T minus 10, T minus 9, T minus 8, T minus 7, 6, 5, 4, 3, 2, 1. Okay, so hopefully Google is as fast as what I was counting. Okay, so let's quickly go over the quiz. Hopefully,
Sorry, one more. There are 2 lucky. So some students are probably logged in twice. So that 85 may or may not be correct.
oh, okay, okay. Yeah, we can see at the end like who did not submit. Okay, so first question: what you can vote actually, or you can try to answer in the chat window. Does this have a logical inconsistency? So is there a logical problem in this code? Yeah, mostly no. Right? Like, I mean, you don't even know what this code is trying to do really at this point. Is it clear what it is trying to do? So you could say there is no logical inconsistency. How about indentation error? Does it have indentation error? No. Okay. Yeah, it looks pretty fine. I just typed it in Colab, so it didn't complain. Is there an undefined variable? Okay, so everybody thinks there is an undefined variable. Yes, J is undefined. Very nice. Yeah, I is defined, but J is not. So J is undefined variable. Yeah, yeah. So it's also I less than J, right? So Shresht who does, so it's not I less than 10, it's I less than J, right? So it's an undefined variable, so you can't be sure. And what about infinite loop? Does it have infinite loop? Okay, so at least undefined variable and infinite loop, everybody agrees. Okay, so let's continue. Okay, so which of the issues faced by a while loop are hard or relatively infrequent? So can you forget to type undefined condition? So undefined condition is it's in one statement, right? So if you forget to type, it's relatively hard, but it's also relatively hard to forget condition in a while loop. However, there are some tricks in which you can forget, or you don't have to write the condition. You guys might have seen the classwork notes from last time, lecture notes from last time. There are some conditions where you don't have to write or some situations where you don't have to write the condition for a while loop, and you can use breaks to make it stop. In those cases, it is possible to miss undefined condition, but it's relatively hard to produce. Undefined loop variable. Can you type a for loop without typing the loop variable? Right, it's almost like syntactical, not really. How about indentation error? Can you have an indentation error with for loop? Actually, what stops me from having an indentation error in a for loop? So I type this, let's say I type for I in range 10, and then I do print I. This is the same problem as what we could have in a while loop, right? Indentation error has nothing to do with the loop. It's relative. You can make the same mistake in a while loop or for loop. The structure itself, so the loop statement or loop structure itself does not make it difficult to produce. How about logical inconsistency? Can I make my while loop logically inconsistent? So I less than 10 instead of I less than 100, or I in range 10 instead of I in range 11. You can have logical inconsistencies or logical issues in a for loop easily. How about infinite loop? Can you make a for loop become an infinite loop? Okay, so those of you who are saying yes, actually, so the first person who said yes, Mohanashri, how do you make a for loop become an infinite loop? Especially easily.
If you said the condition wrong,
Like, yeah, like say, for example, in this, for I in range 10. So what would you set the condition to be?
for I in range, I don't know, I.
Okay, let's see what happens if you do for I in range I. So it gives int object is not iterable, so you can't do this. So actually it's I in range j, those are logical. For I in range j, whoever says for I in range j, you have to make j infinity really. Right, so for I in range of j, so let's see. You'll get an if you do this exact one, you'll get a, oh, this case my j is probably declared somewhere above, so I'll say k for I in range k.
In the for loop, can't you just increment k?
Yeah, okay, try. Let's try that one. So let's say k equal to 0, and then k equal to k plus 1. Oh, so for I in range k in range 100, so let's say k in range 100. It's still finished at 99. So actually, there are only 3 well-known ways of using making a for loop infinite loop. One is to, all 3 of them actually at the end crash. So one is to use something called generator functions. Instead of using range, which is a finite function, that means it only gives finite number of outputs. You can use something called as a generator function. But even that, you have to use a while loop within that generator function to make it an infinite loop. So one of the easiest ways to make a for loop become an infinite loop is to use a while loop in a function and make that infinite loop. So very difficult. The second one is to use some sort of a infinite list. So we'll go through that in a little bit later, maybe like in 2 classes from now. We'll look at what are lists, and we can try to see how to make a list an infinite list. That will also crash actually. So the good thing about it is it will crash eventually, because your computer's RAM will just overflow. Whereas while loop based infinite loops tend to last for as long as you can let them go. Unless you have like a power problem on your computer, they can last. Whereas the for loop based one doesn't really go that far, even with an infinite list. The third one I'm finding it hard to recollect now, but there is a third way also in which you can produce an infinite loop in a for loop. But it also has to do with some trick like that. You can't type something wrong and make it an infinite loop easily, at least. Of course, you can use a wrong condition, but making it infinite loop is really difficult.
I know.
Whereas, sorry, what's okay? Yeah, what's the way?
For I in range, whatever the k,
Okay.
I can just define I as I equals 0 and print I. It'll keep making it 0.
Okay, I equal to 0. Okay, let's try that. But it's still finished. It will keep making it 0. It will still finished. See, it's not an infinite loop because this thing is not showing running forever, right? If I run this top code and let's just say whole number equal to whole number, just whole number equal to whole number, so that I This is a simple blunder in a for loop, right? So if I do this, or in a while loop, if I do this, it's continuing to run forever, right? It's not stopping. Do you see the difference? So this is running forever, whereas this one finishes. It doesn't produce what you want to produce, right? This didn't do what you thought it will do. Neither does the for loop do. The for loop also doesn't do what you want to do, but at least it doesn't become infinite loop. And that's why for loops are a lot more popular. For loops are a lot more popular actually than while loops because of this, especially in languages like Python. In some other older languages, they are probably similar, but for one of the reasons why for loop is so popular is because it's harder to make these mistakes. So infinite loop is very hard to produce in a for loop. In a while loop, it's super easy, right? I could do it without even blinking. Okay, so the next question, do these two pieces of code produce the same answer? No, okay, why not? So anybody who said no, Prince Rahatki or Sasikala, anybody who wants to describe? Because I forgot to define J. Oh no, actually in the while loop, in the for loop stuff, the loop variable definition, declaration, and condition, all of them happen in the same line. So I didn't forget. I think that would. This one has both these pieces of code actually print an answer. I printed the answer before putting them here.
I variable will take the next one. Like it won't stop till that 10. It will go to 11. I think it will take 11.
Okay. Yeah, it will actually probably go to. So it starts at 0, 0 to 2, 2 to 4, 4 to 6, 6 to 8, 8 to 10, right? I'm incrementing by 2, 2.
Yes.
Right, so it will go to 10 and 10 is not less than 10. So
it will go to the next number. I will take the next number, 11, I think. Is it?
Okay, actually it could take 12, but it is less than 10, right? So, okay, so I will go up to 10. Till when does this J go? Yeah, actually, good point, Jerry. Yeah, one prints 30, other prints 65, not the small variation that you guys were expecting, right? So the first loop actually, let's see how this one is easy to illustrate with actually typing it. I should have kept the code now so that I didn't have to type it again. So I'll print I actually, and then also print sum so that you can see what values does this take. So as some of you guessed, so it starts with I equal to 0. Actually, I should have printed I here at the beginning of the loop, not at the end of the loop, so that you know the value it was at the beginning. So I starts with 0, adds it becomes 0 plus 2, sums it up to 0, so it's 2 at that time. Then goes to 2, does 2 plus 2, 4, 4 plus 2, 6, 6 plus 6, 12, 12 plus 8, 20, 12, 20 plus 10, 30. So it only looped through 1, 2, 3, 4, 5 times. This loop went through 5 times, 0, 2, 4, 6, 8. And when it became 10, after I became 10, since I used I less than 10, yes, actually Vibhusha Vadivel, yes, that's exactly the right answer. So yes, this loop relies on I and I'm increasing I by 2 here. Whereas the other loop relies on J. So I still say sum 2 equal to 0. And for J in range 0 to 10, first I'll print J again and then do J equal to J plus 2 and then sum 2 equal to sum 2 plus J. And I print sum 2. So this prints 65 instead of the 30 that the previous one printed. Because as you notice, as you can probably notice, it doesn't matter what you do to the value of J. J keeps getting assigned back into the range that you wanted. So J starts being 0, goes to 1, 2, 3, 4. It didn't matter that you are incrementing the loop variable. So for loop is agnostic to loop variable changes once you set that range. So it's almost like it ignores what you do inside the loop. As it goes back and tries to repeat, it picks the next number from here. So it's a big is it only in Python? In some languages, this is prohibited. Actually, in most languages, this will probably happen. It's not necessarily only in Python. In most languages, this is probably prohibited, but in some languages, especially C programming or older languages, which use a slightly different style of for loop, this does not necessarily happen. There there for and while behaves the same way. In Python, this is very obvious that this happens. In some other programming languages like Java or C# or JavaScript, there are two variations of for loop. In some other programs, there is a for loop that does almost like the while loop, and then there is a for each or something like a for each that iterates through a list. So in some languages this may happen, some languages this may not happen. Yes, Prince Rahatgi, yeah, I think you had to do, yes, if I would have done this comma 2 here, it would have done mostly the same thing as the above one. Let's check that out. So yeah, you're right. So Prince, the way to fix this or make it the same as the previous code is by saying range and then comma 2 here. But if I forget this comma 2, this doesn't do the same as the previous one. This loop, the for loop runs 10 times. This loop runs only 5 times. So that's the big difference. And hope this difference is very clear to you guys. So the answer is no. How about this one? Is the last value printed in both these loops the same? No, okay. What's the last value printed in the while loop? 10. What's the last value printed in the for loop? 9. Okay, cool. So no. Okay. So I'll choose my name and hopefully I chose everything. Let's see if I submit. Yeah, I stopped submission, so too bad. Okay, at least this part is working. Anyway, so that's the answer. So hopefully you guys, it's clear. There are a lot of intricacies to loops. So if this is not clear, please do practice a little bit more. It's not, some of these intricacies are not as obvious actually. You have to practice a little more. There are lots of good online resources you can try. You can change the questions that we are giving as homework and try different questions. You can try to come up with your own problems. We are approaching this from a purely mathematical sense. Yes, what are we going to learn today? Will we have a quiz next class? I have to think about it. I don't know. It's we'll see if we have to have one every class or one every time we finish a section, a given set of topics. I'm thinking of having a quiz once every set of topics is finished, but depends on that. So okay, now that we are about 50 minutes into the class, so what is for this class? Let's go to whiteboard and I'll stop annotations like last time, otherwise the people will start painting all sorts. Okay, good, somebody already stopped annotations. Okay, data types. So some of you already looked at it. Okay, so as we go into this class stuff, let me see if I can share my whiteboard again. Okay, bring it here. Okay, hopefully you guys can see the whiteboard. Okay, can't see much. Okay, can't see it. Let me see if I can stop sharing and start sharing again. Okay, stop sharing and then okay, how about now? Can you see something? Okay, cool. Okay, so let's clear all drawings. Okay, so in today's class, what we are going to learn is what is called as data types. For those of you who don't know what is a data type, we'll start with something that all of you probably know. How many of you don't know what's a counting number? How many of you don't know what are counting numbers? Okay. How many of you don't know what are natural numbers? Okay, if you guys don't know what's a natural number or a counting number, you're all logged in to your computer, you're all connected from your computers. Open Google, look up what's a natural number or a counting number. So for those of you who still think you don't know, that's okay. We'll just go over it. A natural number is numbers starting from 1 all the way through infinity. Numbers that you can use to count items or things, right? So 1, 2, 3, 4, 5, and so on. So this is the set or the list of natural numbers, right? This is called as natural numbers, represented like this in mathematics. I get confused whether the second bar is on the right side or on the left side. 1 to infinity. How many of you know what's whole numbers? Basically positive integers, absolutely. Okay, so you guys are one step ahead. 0 to infinity. So if you add a 0 to this, so up to here was one set. This becomes another set. What is this called? Whole numbers are probably, yeah, whole numbers. I don't know, it differs what letter is used. So usually in some old Russian books, they probably use whole numbers W. In some other books, they probably use I plus, or in some others they use I 0 minus or something like that. Different notations. N is the same notation for natural numbers. W is for whole numbers in some cases. How about if I start writing -1, -2, and so on? What are these numbers? Integers, okay. So this is the set of integers. What next after integers? What was it that you guys learned in school after integers? Rational numbers, okay, rational. Okay, what's a rational number? Yeah, but you probably first learned rational number, right? What's a rational number? Somebody, Divya, Somiseti. What's a rational number? Okay, number that can be represented as a fraction. So something of the form of p by q, right? So that's a rational number. Again, blinking on the notation. I think it's q. It's probably, yeah. These numbers or the letters that are used to represent the sets are somewhat ambiguous sometimes. Some people use q. Some people use R mod. It depends on what you're doing it. So fractions. What is after fractions? Decimals are also. Is a decimal number any different from a fraction? Is 0.2 any different from 0.2 any different from? One second. I want to do that. So is 0. Oops, didn't mean to do this. So is 0.2 any different from 2 by 10? Aren't these two the same? Right, yeah, they're just when written differently, right? Yeah, right. So yeah, they're the same. So we can think of rational numbers or fractions to contain all decimals also. What is after fractions? What is after rational numbers? Irrational numbers. What's an example of an irrational number? Pi. Oh, pi. Wow. Starting with pi. Okay, which is the first? How many of you know? Maybe this is debatable. Maybe it is historical. Which is the first irrational number? Yeah, hard to believe. I have to go back and look at it, but I'll put my bet on square root of 2. I think square root of 2 was found to be irrational, and this confused Greek mathematicians about at least 300-400 years before pi. I think pi came about after square root of 2 came about, because both use really Pythagoras theorem to come to this really. So Pythagoras theorem came first, square root of 2 being irrational came next. In fact, I think this is there even in Euclid's elements. This probably came slightly around or after Euclid's elements. I don't know. I'll have to check that one. But square root of 2 is the first irrational number and the one that was first definitively proved to be irrational. And then pi became proven to be irrational. I think pi being irrational was proven much later, probably like in 1600s. I have to think of that one also. So this is irrational numbers. What's the set of all of these numbers put together called? So these are all numbers that you are familiar with. These are irrational numbers. So we'll call them Q bar real numbers. Okay, so that's a set of all the numbers put together is real numbers, typically represented with a double line and an R. What's after real numbers? Yes, absolutely, Shreyan. Actually, there are fake numbers, and in fact, when they were introduced, a lot of philosophers, mathematicians used to be called philosophers. That's why actually, after you finish your bachelor's and master's, you become a doctor of philosophy. You don't become a doctor of engineering. There are doctor of engineering degrees these days, but doctor of philosophy is more common. Mathematicians used to be what are called as natural philosophers. Philosophers means love for learning, I think. So those who loved learning were also those who were becoming mathematicians. So yeah, complex numbers or imaginary numbers, when they were introduced, they were a big no-no in scientific community or in the mathematical community back then. People hated them. The same way as some of you probably know calculus, the same way they were also, calculus was also hated and absolutely not at all welcomed. So I think C is written like this. Actually, I have to probably do better job at writing a C. But I think complex numbers is this set, the C. So these are complex numbers. What next after complex numbers? And for those of you who think we are not doing programming, we'll come back to programming after this. What next after complex numbers? Okay, so what next after complex numbers? Don't know. How many of you know what are vectors? Okay, not range of numbers, set of numbers. Yeah. How many of you know Cartesian coordinates? How many of you know Cartesian coordinates, like 0.1, 1 on the graph paper? So 0.1 on the graph paper. This is a set of numbers, right? Not a. Yeah. So Cartesian coordinates is a vector in a Cartesian plane. So it's a position vector for a point in a Cartesian plane. So far up to here, up to real numbers, we were talking of a number, right? You could write a given symbol or a long series of symbols, but it was one number. So up to the left hand side, everything on the left hand side was one number. On the right hand side, if when you take a complex number, it is 1 plus 2i. It's a pair of numbers, right? So these are two numbers in the complex side already. So let me erase this part so that I don't put the two numbers after three numbers. So we have numbers, even in mathematics, in what you know already, we have numbers which are single digit numbers. What does that mean? 1 plus 2i. It's the when you it's a complex number. The easiest way to explain is if you have a plane like this, it is a point at a real coordinate of 1 and the imaginary coordinate of 2. It's a point like this. So this is 1 plus 2i. You might have seen this in your charts if in school, like in middle school or in charts you would have seen, right? A point 1.1. So this is same as that. The 2i carries some significance. I is the square root of -1. Because square root of -1 is not any number that we know of. So I plus 2i, and this one is a set of numbers 1, 1. So here we have two numbers. Can you guys think of any instance where you have more than a bunch of numbers? Yeah, if you don't know what these mean, that's okay, doesn't matter. This is just an introduction onto branch out to data types in programming, just so that you guys can follow some of it at least, to see how many of you can follow. So we were talking about a single number, now we are talking about a pair of numbers. How about a bunch of numbers? So vectors in mathematics are a bunch of numbers. Yeah, don't worry if you don't know what's a complex number. You probably know what's a graph, right? If you know what's a graph, you know of a situation where you use two numbers together. On a graph paper, yes, if you're confused, don't worry about it. We will come back to programming. On a graph paper, how many of you have not seen a graph sheet? Vidyut, have you seen a graph sheet? Vidyut Iyer? Yeah, if you have seen a graph sheet, if you have to spot a point on a graph sheet, do you use two numbers or do you use one number? Two numbers, right? Whereas if you want to talk about the number 10, are you using two numbers or one number? When you're talking of the number 10, you use one number, right? So that's what. Everything on the left hand side, the big section, the things that you learn, most of the that you have learned so far are all single numbers or a sequence of digits, but still a single number. Whereas the things on the right hand side are a pair of numbers. On the graph sheet, there is no single number that tells you where 1 comma 1 is. You need two numbers to talk about it, right? If you take a globe, if you take a sphere, how many numbers do you need to talk about a point on a sphere? 3, right? So you need to know where, or if you are in a room, if you are in a room is a three-dimensional space. So you need three numbers, right? So cool. So as you can see, as you go higher and higher, the number of numbers that you deal with increases. Okay, so we started, now I'll probably erase all of this. Maybe there is an easier way to do this than erase all of this. Can I do a new drawing? Does anyone? Okay, I'll save this drawing. Okay, and then clear all of, erase all of this. Okay. So in the numbers that you have learned in school already, there are some cases where there is a single number. You have learned other classifications of numbers, I'm sure. So there are some cases where there is a single number, one number. Sometimes there is a pair of numbers. Sometimes there are three numbers used to represent something. Now, is it hard to say that there are sometimes 4 numbers or sometimes 10 numbers used to represent something? What that something is differs, but something in 4-dimensional space. How many of you have heard of 4-dimensional spaces? Maybe you guys might have watched some videos. Yeah, time, very nice, Darren, do, yeah. So some of you have probably watched some videos about theory of relativity, space-time continuum, or you probably have watched the movie Interstellar. Right, in Interstellar, they go from one universe to other universe, come back to that universe. So they use a black hole to open up a wormhole to travel from one point in space to another point in space in a parallel universe. Yeah, it's a wormhole. Yeah, you use right. So they're going from one same point to same point, but in a parallel universe. Yeah, very confusing theory, but good for a movie. But actually, yeah, it's not actually that confusing. There are actually very serious researchers who do research on parallel universes, multiple universes. If you guys are interested, watch YouTube videos. So there is four coordinates, and the popular one is for space-time. You use 4 coordinates for space and time. 3 coordinates for space, because space as we see it is 3-dimensional. Space as amoeba sees it is only 2-dimensional, because amoeba is a single-celled organism and it just sees a 2-dimensional space. So space-time is what we normally, one context where you use 4 dimensions. Star was got it wrong. The star should be shorter when you go. Yeah, absolutely. Yeah, a lot of inconsistencies happen when you start traveling at speeds of light, and a lot of movies get it wrong because it's very hard to show certain things the exact way on a movie screen. So now, can you think of any situation where we use a ton of numbers? Let's say like 2 million numbers to represent something. And I'm sure when I tell you the answer, all of you probably know, like 2 million numbers or more, let's say 2 billion numbers. Where would you have used it a set of 2 billion numbers to represent one thing? Any guesses? And I'm sure all of you have used 2 million, 2 billion numbers. No, not pi, not scientific number. It's one thing that has 2 million numbers. I'm sure none of you have typed pi up to 2 million numbers. Yes, absolutely. When collecting mass data about something, population statistics. So you probably have heard of some statistics, right? In some statistics context. Any other situation where you have heard of these many numbers together? Let me see if I, okay, so when you see here, right, do you see this? Okay, you probably can't see this one because I'm sharing my whiteboard. Let me see if I can share my screen again for a second. You can probably see my screen, some files and folders, right? I have a PDF document. If I look at its size, for those of you who don't know, it says it is 279,850 bytes, right? Computer storage, absolutely, yeah. So computer storage is where hundreds of thousands of numbers are stored together. So what you see as a file is really just a series of numbers, lots of most commonly 8 binary numbers put together. So that brings us to this notion of what is called as binary numbers. How many of you know what's a binary number? Yeah, ones and zeros, right? Binary. So this is a different type of numbers. So we have ones and zeros. I have to improve my handwriting, 1 or 0. These are more of the numbers you are used to. These are numbers that you probably some of you are used to. 1 meaning yes, 0 meaning no. Yeah, when and what are we going to be coding? Without thinking, if we start coding, there is a lot of danger, Shreyan. That's why we are thinking right now, and then we will code. Coding is not typing. Okay, so if you don't have the patience to wait out, then probably don't attend. So coding is primarily thinking. So we are thinking. So some single digit numbers, some multiple numbers, and then some binary numbers. And then when you go to things like files, you have thousands or millions of binary numbers, and they are files, right? So as you can see, there are different types of numbers that we have to handle. And when programming languages were introduced, they also had to handle different types of data or different types of numbers. Yes, 8-bit, Jonathan, is 8 bits is 1 byte, Jonathan, not 1 bit. 8-bit is not 1 bit, 8-bit is 1 byte. So when programming languages were introduced, obviously they also had to start dealing with real life situations. So they started introducing different types of data or different types of variables so that we can represent some real life objects in programming world also. So it's not always x equal to 0. You can also do certain variables. So now, obviously, all the numbers that were single digit numbers came first. So people first started doing x equal to 0, right? So what is this called in a programming language? This is called as integer. So the data type is an integer. In Python, it is integer. There are lots of subclassifications of numbers in programming languages. We are not going through all of them. We are going through some of them that are going to be useful. So when you say x equal to 0, you are telling the interpreter that x is an integer with value 0, right? When you say y equal to -2, then you are telling the compiler that y is a variable of type integer with value -2, right? So that's what the interpreter reads it to be. So what do you expect to get when I say z equal to x plus y? What do you expect to get? -2. So you expect to get a data type integer with value -2, right? Now let's check. We'll print x, y, and z and check if that is correct. So 0, -2, and -2. So not every number in Python is an integer. When you type like this, those numbers are integers. So x equal to 0, y equal to -2, z equal to x plus 5, these are integers. What happens if I type a equal to 1.2? Is this an integer? Vidyut, is this an integer? No, okay, brilliant. So it's not an integer, it's just it's a decimal number or a floating number. So this one, the data type of this is float. Why float? If you're interested, you can stay back after the class, we can talk about it. There are two big classifications of numbers when it comes to programming. Lots of classifications. One major classification, one is called as fixed point numbers and other is called floating point numbers. There is just a random thing why it is called floating point numbers. One really crude way of thinking about it, right? This number is different from this number, but both of them have the same digits, right? A and B have the same digits, 1, 2, and 0. But the only difference between them is where the point is. No, there is no sinking point numbers. There is only floating point numbers, because the reason you can think of it like this, I don't know what's the origin of the word floating point, but the reason why it's called floating point numbers is primarily because where the point is decides what the value is. It doesn't do anything specially. What does float do again? It doesn't do anything specially. It's just when you say float, it is used, whatever you're used to as decimal numbers or fractions are in programming languages called as float. So equivalent of fraction or equivalent of decimal, and can be used for fractions. So somebody already gave an example. So let's say I do c equal to 6 divided by 5. Now if I print a, b, c, so what do you expect to get for a? 1.2, right? For b, what do you expect to get? Yeah, when something ends in a dot zero, a 12.0 is actually a floating point number. It's not exactly the same as 12. Of course, practical purposes, it's exactly the same. Right, yeah. So for practical purposes, 12 and 12.0 are the same. So let's check if a program thinks 12 and 12.0 are the same. So if we say 12.0 equal to 12, if it prints true, then it's the same. If it doesn't print true, then it's not the same. So let's see. So it thinks that 12.0 and 12 are the same. So it does some, but don't abuse this. If you are dealing with floating point numbers, use floating point numbers. Don't use any other numbers. So it's best to avoid ambiguity, because here this is the interpreter thinking that they are the same. In some other context, maybe you don't want 12.0 to be the same as 12. Yeah, sure. So in this case, as you can see, all three of them, whether you wrote a fraction or you wrote a decimal, they are all coming out to be float, right? They're all showing up to be an integer at the, a decimal at the end, right? And then finally 12.0 is the same as integer 12.0. So we learned two data types. Now I would like for you to try a couple of small programs on your side. Very small programs, don't try too hard. Declare 3 variables, 1 integer, 1 floating point. So just something like declare 2 variables, initialize them to be, actually, yeah, try this. Let's see how. Declare 2 variables and assign them integer values, whatever value you want. Add them, subtract them, multiply them, and divide them, and print the result. Same thing repeat for declare 2 variables and assign them float values, add them, subtract them, multiply them, and divide them. So check out what happens. So please try on your screens. Do you add and multiply them? Yeah, separately. Yeah. So you can print, if your variables are a and b, print a plus b comma a minus b comma a times b comma a divided by b. You can all declare two variables, give them integer values, add, subtract, and then print the sum of them, the difference of them, multiplicate product of them, and the ratio of them. Any decimal is a float. Yes, absolutely. Any decimal. You can use 1.2, 1.3, or any long decimal also, 1.39999, whatever you want. Okay, for those of you who are done typing this up already, yes, floats are just decimals. Yes, absolutely. Floats are just decimals. What you call in mathematics as decimal, even decimal is actually, the reason why they are called float and not decimal is just because decimal representation typically means you are using base 10, right? In programming, most of the representations, does division of whole numbers always result in a float value? Yeah, good question, Tanvi. What did you get in your, when you typed it? When you printed it, did it give a float value or did it give a, yeah, it gave 2.0. Try using the same number, print 1 divided by 1. What do you expect if when you print 1 divided by 1? Any guesses? What do you expect when you print 1 divided by 1? Do you get 1? Okay, Shriya Rajesh 1, Tanvi says 1.0, Ashwath 1.0. So let's print and see 1.0. So this is where you have to be very careful, and that's why data types are important, right? If you add two integers, what do you get? Okay, hopefully you have all started looking, typed all this. So let me type now so that we don't spend too much time on this. So int1, I'll call them integer 1. What do you want it to be? Integer 1, give me some number. Somebody give me a number, 5. Okay, integer 2, 6. Okay, good. So if I print integer 1 plus integer 2,
11.
11. You expect 11 or 11.0? 11. Okay, so let's see. So prints 11. Perfect. What do you expect if I print integer 1 minus integer 2? Minus 1. Okay, let's see. Okay, so prints minus 1. What do you expect if I do integer 1 times integer 2? 30. Okay, 30. Still no decimals, right? Now I'll do integer 1 divided by integer 2. What does that print? 5 divided by 6? 0.833. Nice. So it became a decimal automatically. Same as what you would expect in your school math, right? Like when you're doing it in school also, you would expect the same thing. When you divide, when you add 5 plus 6, you don't expect it to become 11.0. Till here, everything kind of behaves the same. The only time it doesn't behave the same as what you would expect in school is when you do 2 divided by 2. When you do 2 divided by 2 in school or in math, normally when you do it with pen and paper, you expect it to be a single digit 1, a natural number 1 or a whole number 1. But in programming, integer division, at least in Python programming, integer division always results in a floating point number. That's something to just keep in mind because it can cause problems. This can actually cause problems. In some cases, not always. In some cases, if you don't know that this is happening, you might end up thinking, or you might end up rounding it off or incorrectly floor or seal So you can either round it off to a lower number or a higher number accidentally if you're not conscious of this. Nothing bad will happen, but some cases, some illogical things can happen. So as I said, some of you probably already pointed out a floating point number or a decimal. Why we are calling it as a floating point number in programming? Two reasons. One, it's not exactly a decimal number because it's not to base 10. It's to base 2 really. What is printed on the screen is the base 10 representation, but what is stored internally is a base 2 representation. And it depends on where the point is. Where it stores the point changes the value. Even if it has the same binary representation, the point changes everything. So that's for integers. Now if I take two floating point numbers, 1.0 and 2.0, what do you expect when I add them?
3.0.
3.0. Okay, let's see. Okay, 3.0. What do you expect when you subtract them? Actually, let's take the same decimals, 5.0 and 6.0, so that we can see the exact same answers in a different way. So the previous one printed 11.0, this one printed the integer one printed 11, this printed 11.0 minus 1.0. And what do you expect when I multiply? $30.0. Okay. What do you expect when I divide? So in division, it didn't. Both of them are producing the same result, kind of, right? When I divide, they are both giving the same answer. And what do you expect when I do 2.0 divided by 2.0? 1.0. Absolutely. So for division of two integers or division of two floats did not matter, right? It's giving consistent results as what you would expect. Now what if I mix and match? So what if I take a float and add it to the integer? Can I do this? First of all, can I do this? Can I add a decimal to an integer? How many of you think this will give an error? Okay, 1. Sasikala or Sanjukta, Nipun. Did you guys learn some other programming languages like Java or some other languages like that? Yeah. So let's see what happens. So in Python, it actually doesn't matter. In some programming languages, this will give you an error. But Python is what is called as a loosely typed language. And also so what that means is the data types are, actually it's probably not strictly a loosely typed language because there is a type. Yeah, in some other languages, this would have given an error probably. But in Python, at least it doesn't give an error and it does the same thing as what you would expect it to do in your pen and paper math. If you add 2 plus 3.2, you expect the answer to be 5.2, right? Not an error. Python does the same as what you would think of it to do. The only time it looks somewhat odd in Python is when you divide two whole numbers and you expect to get a whole number answer, you get a decimal answer. That's the only weird thing. Other than that, everything else, it behaves almost like what you would do with a pen and paper. So same way, let's say I do this subtraction. Let's do integer 2 minus float 2, just so that we can see that it gives 0.0. So see, it gives 0.0 even though it's the same number. 6 minus 6.0. It's the same number, but it gives 0.0. It gives exactly what you'd expect with your pen and paper math. Can Python solve quadratics? Oh, actually very, very easily. You can solve a lot more than quadratics, right? Even when it is printing this, it's probably doing a lot of figuring out. When I print it, it knows that it has to print it at this size, put a dot here, 8333. It's doing a bunch of computations in the small amount that it takes. But yeah, to your question, Hrishikesh Jayaraj, we will solve some quadratic equations. We will solve some probability problems. We will solve some calculus problems, some statistics problems using Python. maybe in 8 or 9 classes from now, we'll solve all of those using Python. You can do most of mathematics stuff in programming these days. In fact, a lot of mathematicians are using mathematics programs to prove mathematical theorems. There are at least a couple of, now I can't remember the name, couple of well-known problems that are solved using programming. The proof is actually a program. Is it easier? I don't know if it's easier. I think it depends on you. Once you do it, you tell me. So, in fact, actually, I think I was reading yesterday something about it. We'll talk about it a little bit. So, integer times float, again, decimal times an integer gives a decimal. What would you expect when I divide an integer with a float? Float, absolutely. And even if I divide by the same one, so if I divide it by the same one also, 6 divided by 6.0, what would that give? 1.0. So 6 divided by 6.0 would give 1.0, absolutely. So looks like decimals and integers in Python are very friendly with each other, right? So far we don't see any conflict with them. You are able to use decimal and integer almost in a without any conflicts. Do this in some other programming languages and that will cause you lots of problems. But in Python at least, it's very friendly. You can add them, subtract them, do integer divisions the same way as what you would normally do in your school math or outside. Any questions so far? Is this clear to everybody that there are two types of numbers that we can use here? One called integers, the other called floating point numbers, and you can add, subtract them the same way you would expect to do on paper. That's the summary. Okay. If you have questions, please go ahead now. Okay, cool. So now we'll start looking at some other types of variables, and that's why this is called data types. So anybody, what's the next variable type? Somebody, string. Okay, very nice. Not zero. Matthew, what do you mean by not zero? Okay, okay, no problem. So, okay, so those of you are saying string. What's a good example of where, how does float work on a deeper level? Benjamin, we can talk about it at the end of the class. It's actually not that that challenging. It's actually very, very straightforward how floats work. It's just a bit representation of a decimal number where it uses two different values to store one decimal number, the actual bits and the position of the decimal point. It's very straightforward. We can talk at the end of the class, Benjamin, how floats are internally represented in memory. Okay, yeah, well, let's go to strings now. So can you tell me an instance where you talk of something that's not a number? When you talk of data, something that's not a number kind of data. What's a good example or a common example for when asking for input? What do you mean by when asking for input? Printing results? No, those are in programming terms, right? In real life, what are in name? Yeah, so your name is not a number, though some people these days are naming with all sorts of letters. But your name is not a number at least. So it's a, what is a name? What type of data is it? It could be, yes, absolutely. Your name could be a number. Absolutely, there is no doubt about it. But what type of, I mean, you could have your name as a number, but most people's names are numbers, not numbers. Even Elena's child's name is actually not a number, right? It's Z, which is our key or however that is pronounced. That's a Greek letter, so not a full number. And the text 12 at the end is a reference to some popular stuff. So not really a full number. So strings. So when you say type a name, right? We have already typed some of this, so you probably know. I use this single quote to type this name. So I'm not typing like a number where I don't have this. This is what's called a string. a string is just a bunch of alphabets or even non-alphabets. One with a single quotes is a string. So let's declare a few variables. Name variable, one string, integer 1. Right? What is the difference between double quote and single quote? Okay, let's see if there is a difference between double quote and single quote. Name variable 2 equal to name. Okay, so if I print name variable and name variable 2, do you expect to see two different results? Now you got the same. Now if I do this as name variable equal to name variable underscore 2, do you expect that to say true or false? How many of you expect this to say true? Okay, false, true. What will happen when, yeah, we'll see that, Mohanshri, we'll see. We'll do the same kind of operations on strings also. Okay, true. Okay, let's see what it prints. Okay, so it printed true. So it didn't care whether you had a single quote or a double quote. Again, for some of you who might know that, who might have done in other programming languages, in some programming languages, using a single quote is different from using a double quote. In like I use C#. In C#, using a single quote represents a character. In double quote represents a string. But Python is very friendly again here. We are comparing the values, obviously the value is the same. Yeah, actually, as I said, in some languages this wouldn't be the same. So in some languages, if I type this versus this, they are not the same. But in Python, they are absolutely the same thing. So the friendly language that Python is, string is anything between quotes. Yes, absolutely with you. String is anything between quotes, and whether you use single quotes or double quotes, it is the same kind of string. Yeah, Python is very flexible, yes. And it behaves like what you would expect it to behave, like English, right? You don't say something and mean something else. Now, what about these two? When I say one as a string and one as an integer, what do you expect when I print these? When I print one string or integer 1, do you expect to see anything different? Mohan Shri, you have asked two questions. I'll come back to your two questions. No, you'll see the same thing. So absolutely, it prints the same thing. Do you expect these two to be the same? Oops. So it says they are not the same actually. How would that even work? Ashwath, what do you mean by how would that work? There are two different data types, absolutely. Anything inside the quotes are strings, right? So anything inside the quotes are strings, and without the quotes are integers or floating point numbers, and these two are not the same. So the first time where a slight difference between what you would expect, or maybe you are all smart and you didn't expect that this would be the same, but at least when I had seen this first 16, 17 years ago, I had thought that these two would be the same. Oh, okay, yeah. So now to come back to some of the questions that you would logically have, let's take two strings. One string is 1 and two string is 2. What happens if we add up these two? Or even let's say just 1 and 2. What happens if I add one string plus two string? Yeah, we'll go there. We'll go to, when you learned numbers in school, you probably learned it in order, right? Mughal thinks 1 space 2, Shriya Ramesh thinks 1 without space 2, Anish thinks 3. Okay, let's see. So it's 1 without space 2, right? It almost looks like a 12, but let's see, is this equal to 12? And that's not a 12, right? It's just a number, it's just 1, 2. So somewhat confusing, that's why now you have to start being careful. Strings are not equal to numbers. So when you add two strings, it's like putting one next to the other. It's like writing your first name and last name. You're adding your first name to your last name. Right, so here it's not really called addition. It's called concatenation. Absolutely, Mohanishri. So when you add two strings, the result is concatenation of the two strings. So that's the slight deviation, but it's not unexpected again, right? When you add your first name to your last name, you don't expect it to become a formula, right? You expect it to be your full name. So that's the common situation. And again, Python is doing what you would do in real life situations. But it's slightly, if you are slightly confused about this, then it can get a little tricky. Now, what about if I do one string minus two string? What do you think will happen if I do one string minus two string? How do you add a space though? Oh, you want to add a space, you can put another empty string in between and add them. So you get one space too, right? I'm adding a space. You can add a space. Or I can put a dash. What happens if I do one string minus? So Darren thinks 1 dash 2 comes up. Okay, let's see. So it says unsupported operand. What that means is you can't subtract strings. So coming back to your names again, what happens when I remove your last name from your first name? What happens when I subtract your last name from your first name? Is there anything that you expect to happen when you subtract your last name from your first name? No. How, if I subtract Shanmugam from Mugil, will you get Mugil? No, right? So in programming error, in real life also, nothing happens. What does it mean really? It's an undefined operation. What does it mean? Some of you can argue and say, okay, I'll just remove the letters that are common. Some of you might think, oh, I'll get the letters that are uncommon. But there is no clear meaning of Satvik. Learning about input is just asking for input, right? We will learn about those. Those are the easy ones. If you are focusing on the easy ones, that's fine. We'll get to the easy ones later. When I try to add one string and two string, it doesn't print anything. Oh no, yeah. So what did you do, Shruti Satya? What did you do? Can you maybe say that? Okay. Okay. So there is no subtraction of strings. What about multiplication of strings? No. So let's see if it allows us. Same problem. So obviously, if it doesn't allow subtraction, multiplication, does it allow division? No. Okay. Let's see. Doesn't allow division also. So strings don't allow. So string is anything within single or double quotes is a string. You can add two strings. The result is concatenation of two strings, but you can't do strings don't allow subtraction, multiplication, or division. Can you add strings? Oh yeah, that's a good question, Kishan. So what happens if you add a string to a number? What do you expect to happen? Error again. Okay, let's see. Error. So what's this error? This says must be string, not int. So something else. So basically, if you're trying to add a string to an integer, it doesn't work again. You need a formatted string. Yeah, no, Mugil, what does this do? So Mugil, looks like you're a little bit ahead of others. So let's try this, right? So string name equal to name. Mugil, what happens when I do int of this, right? What happens when I do this? Error. So you should, right. In some cases, it is possible to add strings by converting them to integers and then add to integers. But in most cases, it's a bad practice because unless you are really mixing up your numbers, it's almost like saying I'll add my name to my score. What does it mean when you say I'll add my name to my score? You can write your score next to your name. Would that work? String 10, integer, int of string 1. Yeah, it could work. Ashwath, it could work. But again, you guys are looking at what will happen here, Ashwath. When I say string name and say int of string name, Ashwath or Mugil, what would happen here? Right. So for those of you who don't know this, let's go a little slow. There is a way to convert strings into integers and integers into strings. And that's because sometimes you need them, not because it's the right thing to do. Sometimes it's probably beneficial. You can convert. So let's say I start with integer 3 equal to 3. I can convert this into a string by saying str of this integer 3. And now this is the same as this 3. So let's see if that prints it. So just a quick recap so far. So first things first, we learned about numbers that are like integers, no difference than what you would expect. Then we learned about decimal like numbers, no difference from what you would expect. You can add, subtract, multiply, divide 2 integers, 2 floating point numbers, 1 integer to a floating point number, and that all works as you would expect. Then we learned about a type of data called string, which is anything that you would put in single quote. Even if you put a number in a single quote, it's a string. These strings are different from numbers because they are used to represent names or other types of data. If you want to use a number, you should use a number. If you want to use a string, you should use a string. When you make a string an integer to add to another integer. So, right. There is Meda, Swarna, biology. There is no difference in your example. There is no difference. But let's go through additional things later. So when I do this, right, when I print this string, when I say print string of this, it works. It gives me 3 as what I would expect, right? It is giving me a 3, but it's the same as this 3. So when I do this, it should give me a true, but it is not the same as the number 3 anymore. So 3, let me show you so that all the variations are clear. 3 is not equal to 3 and 3 is not equal to 3. So same, both ways it's not equal. Whereas string of the 3 is equal. So whether you put double quotes, single quote or double quotes, things in quotes can be equal to things in quotes, but things in quotes cannot be equal to numbers unless you convert them and them that way. Hopefully this is clear. So as you can expect, the first one is true. So this is a string because I said str of integer. So string 3 will be equal to string 3. Yes, absolutely. So let's try that. String 3 is equal to string 3. And 3 equal to 3, right? String 3 equal to string 3, number 3 equal to number 3. The last two things print a true, right? So strings can be equal to strings, numbers can be equal to numbers, but strings cannot be equal to numbers unless you do some special processing on them. And you can convert a number into a string by using str of this, but it doesn't do any interesting things. But it can cause lots of problems. So if I declare integer 4 equal to 4 and then try to add a string of integer 3 to integer 4, what will happen? What's wrong with converting? This is what's wrong, Nipun. You'll get errors. Right, Nipun, you answered your own question. What's wrong with keep on converting? This is what's wrong. If you use the wrong type of data for storing, if you use a incorrect data type, you could easily end up making illogical errors. So use the right type of data when you want to store something or when you want to represent something. It's very important, and I cannot say how important, and maybe in the homework that you get today, you'll see how confusing or how hard it could become once you start missing things and mixing up data types. So addition of a string to an integer is probably not going to work. Let's see. And as expected, gives an error, right? Must be string, not int. And also addition of two strings, as you have already seen, gives you something completely different. It doesn't give you real addition. Will there be any classwork? This is classwork. You guys can try the same thing as I'm talking here. You can also try variations on it on your computers if you want to. I'm going slowly because this is very confusing, and without understanding this thoroughly, you'll get super confused 2 classes from now. So I'm going really slowly today, not because I don't want to go any faster, but because I want all of you to completely understand all the possible problems with data types. So when you add 2 strings together, we get concatenation, not addition. So this is with just integer to string. Now what do you do if I give a, now some of you have mentioned already, for those of you who know, one of the popular things that most people learn when they learn Python first is this thing called input. You can say x equal to input of please enter a number. And when you do this and say print x, it prints whatever you entered. For those of you who don't know, this is nothing fancy. It's just like if you go to a website and it asks you to enter your email ID, this is similar to that. It just asks you to enter a number. That's all. So let's see what happens if I run this. See, it's asking me like an email ID. Please enter a number, right? And it's waiting for me to enter my number. So if I enter 125 and hit enter, then it prints 125.
Camera.
So all of you can try, like you can try different things if you want to try input, please enter your name, please enter, can you put that in chat? Yeah, of course I can put that in chat. So try this one, please enter different things. Oops. Instead of please enter a number, you can type whatever you want and it will type that. It will show you that different thing here. Please enter your name. And then it will type whatever you give it.
Enter your name.
No, that's not what we're supposed to do.
Right, yeah, there are in other languages, yes, there are different things. I don't know if there is a read line in Python. Let me see if there is a read line in Python. I don't think natively it is there. Yeah, it doesn't seem to be there, read int, read line. In a lot of programming languages, there are lots of ways to do the same thing. Python is again very friendly in that way. There is one thing to do one thing and it works the way you expect it to work in a commonsensical manner. In other programming languages, because they are what are called as strongly typed programming languages, since you cannot mix and match integers with strings in a friendly manner, in lots of other programming languages, you have a ton of stuff to do the same kind of thing.
நீ பண்ணி சப்மிட் பண்றியா?
அவன் சொல்லி கொடுறது இதெல்லாம் சப்மிட் பண்றது.
Yeah, you guys don't have to submit. You can just do it on your in your computer and see how this works. So now let's see, I'll ask them to enter input. Please enter your first name. And then I'll also ask them to enter, please enter your last name. So I'll use good variable names, basically first name, last name. And then I'll say print full name is, see, I can just keep adding strings, right? So full name is first name plus last name. So please enter your first name, please enter your last name, and then you can concatenate everything and say full name is, this is of course not programming, this is just to show you that it works this way. So please enter your first name, Karthik, last name is Malasani, and then when I enter it, it prints full name. Are there any limitations? Yes, absolutely, Ashok. Good question. There are lots of limitations to using input. First one is it does one at a time, right? I knew I had to ask 2 inputs. I don't know, actually maybe there is a way to make it, at least I don't know of asking for multiple inputs in one shot. It's little confusing to ask for multiple inputs in one shot. The second big disadvantage and the more important disadvantage is, let's see if I want to enter a very trivial calculator, right? Please enter first number. I want to ask somebody to enter first number, last number, or second number. I want them to enter two numbers. So I'll give these good names, first number, last number, or meaningful names, not good names. You can. Then I want to do sum of two numbers, sum of the numbers. So for those of you who already know, what would it do? So if I give two numbers as 5 and 6, what does this print? Any guesses? 5, 6, good, Manishka, Aditya, perfect. So if you do this, it prints 5 space 6 because I put a space here. So it is printing 5 space 6. So Ashwa, this is another limitation of an input function. It only takes everything as a string, right? So if I had done product of the numbers is this, then what do you expect the product of these two numbers to be? Error, absolutely. First number is 5, second number is 6, and it can't multiply sequence by non-int. Whatever, some error basically. It gives you some error that says it's not an integer. I can convert, yes, that's a good point, Anish. We can convert this. Now for those of you who are interested in this, we can convert, right? So we can say first number is equal to int of first number and second number is equal to, but can't you convert? Yes, I'm converting. Yes, second number is equal to second number equal to int of second last number. Oh, last number, not last name. Or I'll just use the same thing. Last number is equal to int of last name. Now this should work, right? Now product of the two numbers should give you 5 times 6. That's the expectation at least, right? Yes, we'll go over the full name thing, Shruti, in a second. So if I type 5 and 6, and this gave me an error, must be string not int, so I must have done something wrong somewhere. Last number, oh, I'm adding this one, so sorry, this is the problem, that's not the problem. So let's do it. So 5 and 6 and 30. So once I convert to int, as Anish pointed out, it worked, right? It looks like it works. Yeah, I will go over the full name thing one more time. But let's look at the integer. Let's first the full simpler variation. So I asked for input to enter full name, first name, and then I asked for input for last name. So I asked the user, whoever is entering, to enter their first name and last name. I captured the input into two variables, and then I can concatenate those two variables. Because this input function returns a string. If you can see here, it shows at the top of the variable, it says str first name, right? It knows that it's a string. Same way last name, it knows it's a string, right? So when I add two strings, like what you would expect, it concatenates the two strings. I even added a empty space as a string to concatenate even more so that I can get first name space last name. If I do the same thing with numbers, things start misbehaving because I cannot add two strings because this function returns a string and I cannot multiply two strings. I can add two strings, but I cannot multiply two strings. But Anish or some others pointed out that you can convert it. You can convert this integer into a string. Sorry, this string into an integer. If you use this function int and within the parentheses give the same variable name, if you do this, then it converted the numbers that I typed into integers. Then I could do this. How can I convert? So you can say product equal to first number times last number. And now if I want to print this product of both numbers is, can I do a plus product? Do you think this would work? So I converted both numbers. Mughal is saying something. Yeah, Mughal, that's exactly what I'm doing, right? Yeah, you can do that, Mughal. But there is a problem with that also, right, Mughal? We'll go to that one. So if I do this, how many of you think that this will not produce an error? Okay, does anybody think that this will produce an error? Okay, so let's run this, and it asks for 2 inputs and says error. The reason it's an error is because I'm adding this string to this number, right? I'm adding this as a string. When I look at this product, it is an integer, right? Can you see that this is an integer on my screen now? But this whole thing is a string. Product of both numbers is a string, right? This whole thing is a string because it's within single quotes. Adding a string to a number causes a problem. So what should I do? I should convert this into a string, str of product. And then same 5 and 6. So product of both numbers is 30, right? Nothing interesting. So looks like it works, but let's try this one more time. So when I ask for this input, instead of typing name, what if I type A in it and B in it? So what do you expect happens now? Right, good point, Ashwath. Yeah, there is a way to check for the data type of a variable. So when I give A and B, so now let's quickly recap whatever we have done so far. We did these many things with input. So we asked for an input. The simplest thing, we asked for an input and it shows this box. You type into it, we can get that into a variable. You can ask for multiple inputs. It asks for multiple inputs. Each of the things that is captured in the input is a string. You can then concatenate those 2 strings. If you try to do any other operation other than concatenation, it could give problems like multiplication or subtraction. It will give you errors. If you are confident if you are asking for a number, and if you are confident that whoever you are asking for is going to very sincerely and honestly enter a number, then you can convert it to an integer. After that, it behaves like an integer. You can also convert it to a float. After that, it behaves like a float. No challenges there. But if you try to convert it, and if the person whom you are asking gives you some bad inputs, then you get an error again. So how to make your program not get this, not get the error in this case? So I don't want to convert if this is not a number. So is there a way I can check before I convert? Anybody wants to guess? You can make it keep repeating until the person enters a proper input. Absolutely. But how do I check? How does computer know x equal to input? The input in that should be a number. And yes, computer actually does not know, Vidyu. That's the problem. Computer does not know. Can you use try and catch block? Yeah, you can use, but that still gives you an try catch is just a way to handle the error, not to prevent the error, right? How do I make sure I don't use the int before? So if I can check that this is a number, then it's fine, right? Is there a way to check that it's a number? Type of, okay, so let's see, type of 3. Okay, let's just try this. Somebody said this answer, so let me try this. Type of 3. It says int. Can you see this on my screen? When I said type of 3, it said int. Yes, Mohan Shri, we can use if statement, but what should be in the if statement is what we are going through right now. So before you convert a user input, you can check if the user inputted a number. And how would you do that? You would use an if statement. If type of first number is equal to what? Is equal to int. Okay, Mugil says is equal to int. So let's check if that works. So let me put that here and say if type of 3 is equal to int, print it's an int, else no idea what's happening. Okay, so it says it's an int. Right, type Shruti Satya gives you the type of the variable. If you give it type of 3, it says integer. Type of 3.0 says it's a float, right? Type of 3 with a single quote says it's a string. Is this clear? So type gives you what data type the variable is. So then why does inputting a letter give an error? Vidyut, inputting a letter did not give an error. What gave an error was me trying to convert it. So when I said int of first number, that's what is giving an error. This is giving an error. Yeah, it can detect actually. There are lots of types and it can detect types. So now I can say if type of first number equal to int, then I'll convert this. If type of last number equal to int, then I'll convert this. So now I'm making the program more robust. It will work when you give it an integer. It will probably not crash when you don't give it an integer. But what about product? Can I do this product if I give non-integers? Why is there a, oh, this one, yeah, we'll go through that in a second, Vijayata. We'll go through this. Why is there a plus sign here? But how about if I want to do this? Here, should I also check whether these two are numbers? Should I check that? Right. So I should check that both of them are numbers, right? I can't just check that one of them is a number. I should check that both of them are numbers. And how do I check that both of them are numbers? And okay. So if the first one is a number and the second one is also a number, then only I want to do this product. So some of you are asking, why did I do this plus string? What is the data type of product? Vijayata, what is the data type of product? Int, right? What is the data type of this product of both numbers is? What is the data type of that? String, absolutely. Can I add a string to an integer? No. And that's why I said string of product, and I'm adding those two so that I can get concatenated result. So I'm concatenating product of both numbers is, and I'm converting the product to a string and then adding those two together. So now if I run this, if I give it a 5 and 6, so we did something wrong. Let me see. If type of first number equal to int, okay, let's see. Type of first number. Okay, let's see what it prints. Okay, so reassignment. So this is an interesting problem. Even though I have cast these two things, it still thinks that it is a string. So the best way to do is probably to say type of first number int and last number int. and then use these two things.
Hey Karthik, what
Yeah.
if you say if type of first number is not equal to int, then you convert it to int?
Oh, here?
Yeah.
Then I will probably get name. If I input A as a alphabet, then it will try to convert as int and it will give an error.
Okay.
Right. So I'm only looking for integers and only casting them, because if I don't convert, I can't multiply. The reason I'm converting is because I want to multiply these two numbers. If I don't convert, then I can't multiply. If I convert when they are not integers, then I'll get an error. So first I'm converting because I want to prevent one error. And if I blindly convert, then I'm going to get another error. So all this additional checking. And a lot of times, just so that you guys know, a lot of times this is what takes a lot of effort in programming. If any of you used any app on your phone, played any game and it crashed, or it has an error, yeah, no, Ashwath, you can do that. Yeah, if your app crashed, then you will know that some of this is the reason. Basically, they either would have not checked for some input, they would have not checked for some output, they would have not checked for some condition, and that leads to some illogical thing happening, and that causes apps to crash. So when you do a simple program like 5 times 6, everything looks hunky-dory, it looks super easy, and it looks like what you do on pen and paper. But when you start dealing with programs, things start getting difficult pretty quickly. These data types can become a big nightmare. In fact, one of the more popular ones, I don't know if it's a story or if I'm being right, I'll Google after I tell the story, is in one of the earliest implementations of Apollo space program, engineers at NASA had used a certain type of data type to represent pi up to 6 digits or up to 10 digits. And that data type did not work out well enough, and they got some overflow errors or underflow errors, and that resulted in some huge cost losses. What is the first number? Yeah, it's a separate variable to save the integer. First number int is a separate variable to save the integer, and last number int is a separate variable to save the integer. Can you put comma instead of the plus? Yeah, I can put comma also. I think if you're asking, can I put comma here in the print? Yeah, I can put comma also. So let's see if this one moves forward. This is still not. Oh, I'm still checking these same things. So first number int is undefined. So pretty tricky ones. And then let's check this one, last number int. And now I don't need this anymore. Whereas I'm
Just
just
convert
checking.
to an integer in the input statement.
Sorry, what is that?
Can't you convert the input statement to an integer by using int?
Right. So you're saying I can do this? Is that what you're asking about?
Yeah, and then it'll just already be an integer.
Right. What if I type my name in it? It will give me an error, right? We already saw that, right? That's one of the limitations of using int. One of the limitations of using input. The input function always returns a string. So it says clearly, read a string from standard input. So it returns a string. It doesn't return an integer. It returns a string. And if you do int of this, then it will give you an error. It will not work. Or I must be doing something terribly silly otherwise. If first number is equal to int. So actually looks like there is really no straightforward error, because when I do this, if first type is equal to int, let's check print of type of first number equal to int. So it says false. So it's not an int. So it's almost like we have to try to make it an int and then see if it doesn't fail. So this is something where maybe you would want to be very careful using these things in the first place. So if you want users to enter inputs as integers, it's very difficult to restrict to that. And this is an example, right? So to make this work, you really have to try something like this. Actually, we'll skip this one. We'll come back to this in a little while later. But just know that it is fraught with errors, basically. If you just do the simple program, the seemingly simple program, you can run into a lot of problems. We get as and string as an input. Isn't integer in the though? Is it? No, it's not. That's the problem, right? Like whenever I do this, whatever I enter here, it doesn't matter. Whatever I enter into this box is a string. I declared this. So this is. So whatever I put into these boxes, whether I put 10 and name or whatever, it's a string always. So conversion of these things is fraught with errors. We will learn something little later because I don't want to go to that one today. We'll learn something little later on how to do this. So far we looked at 3 types of data: integers, floating point numbers, and strings. While integers and floating point numbers are friendly with each other, integers and strings are not so friendly with each other. And we looked at this function called input, which can be used for asking for input. So that's the 4 things we looked at in this class today so far. Now we'll try to look for some other types of data. So do you know any other types of data which you might have heard of or seen? Tuple, wow, Darren, little too hard. Like anything that is only single number. Okay, some single number based data types. Shruti, lists is a data type, tuple is a data type, Darren, that is true. Boolean, absolutely. So when I said type of 3 equal to int, it printed true, right? This true is not a string really. This true is what is called as a Boolean variable or Boolean value. So I can actually say Boolean operator. Yeah, Boolean operator is different from Boolean variable, right? Boolean operations are different from Boolean variables. But Boolean variable, basically, if I want to say, are these 2 numbers same? Are these 2 variables same? So I will declare 2 variables, number equal to 1 and say x equal to 1. And I want to know if these 2 are the same. So I can do number equal to x. And this returns whether it is true or false. When I said this returns whether they are true or false. It says false. So Boolean variables have only 2 values, true or false. These are very helpful. You have already used these without recognizing these. When you wrote your loop to say if I less than 10, it is using a Boolean variable or a Boolean condition to check I is less than 10. True, then go ahead. Else false, then stop. Right? You have already used this without actually calling it Boolean, but you have already used it in almost all your loops. So that's another data type called bool. It only has 2 values, true or false, and it's helpful in checking for conditions. When you say number equal to x, or when you do this double equal to operator, this is called equality of comparison operator or equality operator. You can check. It only returns true or false. It will either say it's true or it's false, or an error. Error is not what it returns. It can crash, but it gives you whether it is true or false. Any other data types somebody knows? Someone said date time, so we'll just quickly go through date time also. So unfortunately, date time is not a native one, I think. So you should say import time and say start time equal to time.time. And then if you print start time, what do you think it will print if I print start time? What do you guys think if I print start time? What do you think it will print? 0, 0. Okay, let's see. It printed 1,595,702,887. What is that number? Right. So time in Python is stored as a floating point number, It's the number of, yes, absolutely, Sai, sure. Sai Shri Satya. It's the number of, I think, seconds. Let's see. What does time it? I think it's the number of seconds from 000 from first AD, first date in first AD or first date in 1900. It's from one fixed point. Yeah, it constantly changes. So if I keep doing this again and again, see, it's changing in like small digits here. If you notice, this got 76, this got 33, this got 84, and some digits are increasing. So it's some number of seconds since then, a few billion seconds. I'll email the homework, Jonathan. Don't worry about what is the homework. I'll email the homework. So we'll focus on learning variables now. So far we looked at 5 types of variables: integers, decimals or floating point numbers, strings, boolean, and times. These are all numbers that are single digit numbers. Why is it billions of seconds? How many seconds are there in a day, Darren? How many seconds are there in a day? Yeah, that's how many? That's 86,400, right? 3,600 seconds in an hour, 86,400 seconds in a day. How many seconds are in a year? No, 365 times 86,400, right? So in 1 year itself, there are 31 million seconds. So how many years is this? If I take this number and divide that by this, we'll know how many years this is. Oh. Order of operations mistake, amateurish error. So it's 50 years. So this is counting from some date in 1970. So when you say time in Python, it's counting from some date in 1970. Oh, I didn't really change anything. Can you guys hear me? Okay. Can't hear. Okay, let me try to disconnect and connect again. Is it better now? Okay, cool. Okay, fine. Okay, so basically Python counts dates from some date in 1970. When you say time.time, it is counting how many seconds have elapsed between now and a fixed date in 1970. Why 1970? I think that's the year in which Unix was born. Why? Because that's the year in which a very popular programming language on which most of the modern programming languages have been built, called Unix, was born, or operating system, not programmers. Unix was born in that year, and a lot of programmers probably like to do it that way. No real reason, actually, to be very honest. It's just how they decided. Whoever is the guy who decided this decided it to be that way. It could have been any other date. Anyway, so coming to, some of you have pointed out, can variables be data types to question mark? Mohanashri, are you talking of some languages like Java or C# where you had nullable data types? Yeah, let's not confuse that. After the class, if you want, we can talk about it. Yeah, there are nullable data types. We'll not do that right now. We can get to that little bit later. So for now, we are going with some 5 integer, decimal, string, boolean, and time. 5 basic types of data. Yes, Shruti, now we are getting to that. All 5 of these basic types of data were all single digit numbers or single number. When you printed, you are getting one number or one series of characters. Symbols like that, Nipun Nagendra, are all strings, right? All symbols are strings. Now, what if you had more than one data value? So what if I wanted to save a Cartesian coordinate point? Date data type, date, actually I don't know. To be honest, I don't know whether it's a date data type. Let me see if there is a date data type. I'll Google date data type in Python. There may be one. Yeah, date is not a data type of in Python. But we can import a module named datetime with dates as data objects. So it's a little more complex. So date is not a native data type. Time is also not a native data type. It's just stored as a float, right? When I do type of string here, type of start time here, and I print this, let's see what it prints. It printed float, right? Yeah, you can import random numbers and so on, but they're all single digit numbers. What if you had more than one number? What if you wanted to use numbers to represent some point on a graph chart? So single digit data types are that we discussed in the class are int, float, string, and bool. Time is not a data type by itself. Time is stored within a variable of class float, but you can think of it as a different type of data, but it's not stored as a different type of data. So some other data types, like if you want to store a pair of numbers, you could use, will the time ever reset? No, that's the hope, right? There is no time going back. Time only goes forward. So yeah. So now let's look at when you want to represent more than one type of data, and we'll continue from here in the next class also. So if I want to represent a pair of numbers, I can do what is called as a list. Right? It's a pair of numbers or a bunch of numbers. You can put millions of numbers into this also. Right? This is what is called as list. If it's just putting it in square brackets and separating the numbers with commas. You can call it, in some languages it's called array. In Python it is called as list. If you don't want your numbers that can't be changed, you can put them in normal parentheses instead of square brackets, and then it's called a tuple. So let's see if I type this type of numbers and type of it's printing just the last one, so let's print both of them. So one is printing a list, the other is printing a tuple. So now things start getting different. Unlike what you would expect when you're writing by hand, these two things probably don't mean two different things for you. But to Python, they represent two different things. When you use square brackets and put a series of numbers separated by comma, they are list. When you put normal parentheses, they are a tuple. A tuple is a list that cannot be edited once you create it. So if I want to change this list, it wouldn't allow me to do it. And why would you use a tuple? If you want to say something like 0, 0 is the origin. So if I want to declare a point called origin, you don't want your origin to be changing, right? So if I declare origin as 0, 0 with a square bracket list, yeah, so Shreya, those things about faster, slower, those things we can talk about later. They have two different purposes. That's the primary thing. A list is a collection of numbers. It's a collection of numbers that allows you to edit the numbers after you have put into them. Whereas a tuple is a collection of numbers that does not allow you to change the numbers after you enter into them. It can be anything. It need not be number alone. You can be names, right? Names. I can say names, and we say Shreyan and comma. I'm just typing some names that I can see from the screen. Nipun, or who is the one? Who is Vijeta. So these are the three names I see in the last few messages. So I can type this. I can print this. And if I type class of this one, it would still be a list. Whatever the type of this is a list. So if you look at it, the first one and the last one are both lists. Even though the first one is a list of numbers, the last one is a list of strings. So lists are just collections. Let's see if you can make an empty tuple. That's a good question. So empty tuple. So let's see if you can make an empty list and an empty tuple. So didn't complain, but let's see if I print what happens. So empty list, empty tuple. But it makes no sense, right? Like, why would you make an empty tuple? Because what does it mean? Once you created it, you couldn't change it. Why do you want to use an empty tuple? There may be some usage. I don't know. I cannot think of a good example where you would want to use an empty tuple. There are a lot of good examples of an empty list. So these are collections. So just to quickly summarize, because we have only 1 minute, we looked at 4 data types that are single digit numbers. They are int, float, string, and bool. One data type that is called time, that's stored as a float. And we started looking at what are called lists and tuples. These are collection. So this is what we looked at in this class. Lists are Python's greatest tool. Absolutely, actually, yeah. Lists are Python's greatest tool. So for those of you who are interested, you know this code, right? You guys wrote it in the class for I in range 1, 1000. Sum of this, right? 1001. This will give us the sum of the first 1001 numbers, right? If I do this. Here, this range function actually is returning a list. Yeah, next class. Yes, all indexing and list processing is next class. This class is just about that there are different types of data. We'll go over for 5 more minutes because you guys joined almost 15 minutes late. So, or maybe 15 minutes because you all joined 15 minutes late. So let's see. This is really returning a list. And that's why when you change the loop variable within the loop, it didn't matter because it always goes back to this list, takes the items from that list. Yeah, we'll do all list operations in next class. But a very interesting thing in Python is I can write this whole code in one line, basically. I can say, I can create a list I for I in range 1, 1001. And then I can just do sum of this and print of this. Oops. It is not callable. I must have done something wrong. Oh. For I in range 1001. Nope. Doing something wrong syntactically. So let's try for I in range 1001. No, I know if we remove the range, yeah, but this is called as list comprehension. I'm trying to do something. Just let me figure out the syntax 1 second. So syntax errors are common. Trying to figure out the syntax. Okay, looks like in the editor we are using this is probably not working, but this is called as list comprehension, and you could do something like this. Once we share the homework solutions, you can see you could do just this I for I in range, and this is just a list, and you can sum up the list. It may be this editor. I have to figure out what to do in this particular editor to use list comprehension, or maybe I'm typing something wrong. No, I'm typing right. Yeah, maybe in this editor I have to type it slightly differently, but in some other editor, actually, let me try list numbers equal to I for maybe this is what it is. No, yeah. So not sure if this is something that I have to figure out with the syntax or with it, but you can try this. You can try this on some other editor. Yeah, it's PyCharm is probably an editor. I haven't used it before, but you can try. No, Meghna, class is not over. Since everybody came late, we are continuing a little longer. So far we have seen some single digit data types or data types used to store one value and data types that are used to store multiple values. We'll continue on the data types that are collections of multiple values. We'll go over a few more collections. One of them is called a dictionary or a key value pair. We'll go over these collections in next class. If you guys don't have any questions, we are done, and this is the session. This is what we covered in this session, a summary of it. So homework as usual, I'll email you 5 questions since I went over by 5 minutes already. I don't want to make you spend some more time. Yes, int, float, string, bool, list, tuple, dict. Those are the 7 data types that we learned or we will be learning. And most probably those are good enough for most of our users. Complex is, you can use a list to store a complex number, or you can use this basically. You can say a equal to 2 plus 3i. And when you do this, let's see, 2 plus 2j. Yeah, so this is now a complex number. So let's say type of a. So it's a complex number.
Don't forget to subscribe and like. If you have any questions, you can email info@agoramatrical.org or comment below and we'll reply back. Maybe. And if you want to see practice things or anything about us, you can visit our website, which is basically the end of the email, but without the info and the end. So bye!